Hi everyone, I'm pouyakhalaj.architect. In this video, I'm going to take a building facade that I found on a Pinterest and turn it a real buildable architecture model. First, I analyze the facade and retrace its real dimension in AutoCAD. Then I model the project accurately in Revit. And after that, I bring the model into a D5 Render and create a realistic render. This video shows my full workflow from reference image to the 3D model and final render. If you enjoy an architectural workflow like this, don't forget to like the video and subscribe the channel. Let's get started. As the first step, we select the facade design from the Pinterest. The image is a high-end architectural render with clean and well-balanced design. The main challenge here is how to extract the real dimension from the single image. In this part, I'm going to show you a practical method that will help you a lot of future projects. For this process, we use AutoCAD. I will import the reference image into AutoCAD and use it to estimate real-world dimension. This will allow you to model the facade accurately as possible and recreate it in Revit almost exactly like the original design. Now let's open up AutoCAD. We copy the image and paste it in using Ctrl-V. Feel free to import it at any scale you like for now. It doesn't matter, because we'll fix the scaling in the next step. We'll use the X-line or line command to draw the impulsive line on our image. First, I draw a line for the floor level. That's the lowest part of the building. Then the second line will represent the underside of the ground floor solid. This way, we are defining the height of one story. I can draw the vertical line at this stage, which shows the building width. Now I select all the line and the image together. Then use the scale command. After running the scale command, I press R to activate the reference object because I want to set the size. Now I can specify that the distance between my horizontal line is, for example, 3.90. Is adjust my image and the length I draw to match the actual dimension. With this way, we made the shape closer to the real what. We now have a good guide for us. The real size may be different, but the shape will match overall. Now, we can find out the size of the outer parts too. Now we can figure out the rest of our measurements. For example, here we can see that the height of the outer floor is approximately 4.20. We just need to round the size a bit. And now, we are going to measure the width of the building. To start modeling in Revit, we need the floor level height and the building width. Then we'll go back and extract the necessary measurement from the photo using the same method. Now the exciting part begins, and we are heading to Revit to start modeling the project. We open a new project, and the first thing you should always do is set the unit in Revit. For project unit, press UN. I always work in meters, so I set the length and distance to meters, matching the units being used in AutoCAD. I will just set the decimal place to 2 digits. In the next step, we are going to bring all the level we got from AutoCAD into Revit. For this, we can open any elevation view. It really doesn't matter which one, as long as we can see the level. Revit already has a default floor height. So, all we need to do is match it with our first floor, which is 3.90 meters. Then we'll simply add the rest of the level based on that. To add level in Revit, we have two main methods. The first one is drawing a level manually as a line. The second method is defining the distance between the next level and the previous one. And this is the method I will always use. For this, go to the Architectural tab, select Level, and start the command. Then from the Modify panel, choose a peak. In the Offset field, you can enter the exact height you want. Once the ground floor is set to 3.90 meters, we define the next height for the upper floors. The height is 4.20 meters. And since each floor needs two levels, we enter this value directly in the offset. This way, we created all the levels we need. Now we can simply go to one of the levels and start drawing the walls. For this step, we already have the building that measured in AutoCAD. However, since we don't have the exact depth of the building, I'm going to enter it approximately for now. For the building width, since we already have the exact measurement, I'm entering 7.80 meters. For the depth, I set it to 15 meters. After drawing the perimeters walls, we need to use the floor tools to create the slab for the floors and ceiling of the units. To create the slab, all we need to do is run the floor tools. I usually use pick lines and for now select the outer edge of the walls. Then I simply confirm it and the floor slab is created. Now I'm going to remove the front wall of the building, the symbol that contains the parking entrance in the 3D view of the image. This helped me clearly identify the facade direction when working in a perspective view. At this stage, we need to define the balcony area on this floor. First, we need to determine the balcony width. To do that, we draw a vertical line from the finished edge of the balcony and measure the distance. In this case, the balcony starts approximately 5.20 meters from the right side of the facade. I'm also going to do one extra step here. I will extend the slab inward by the same thickness as the wall. So we end up with a single continuous wall all the way up to the roof, similar to what you see in the reference map. Normally, we wouldn't do this in a real project, but since this is just for visualization and the simulation, it's totally fine. I move the slab inward by the wall thickness, use a fillet to join the edge, and then delete unnecessary line. I'm setting the balcony depth 2 meters, starting from the right side, which is already offset by 5.20 meters. I remove the extra line and then confirm the sketch. Just like that, the slab for the first floor is created. I can now copy it to the other levels and repeat the same process for the remaining floor. For now, I'm keeping everything approximate. As we move forward, we'll refine the model and match it more accurately to our Pinterest reference image. Now, following the same step, we create this slab for the top floor as well. After that, if we look at the original reference image, we can see that the side walls extend higher than the roof. I know, this isn't the exact height, but for now I'm going to set it to 4.20 meters and adjust it properly later. Now let's move on to creating the windows. For the windows, I use a curtain wall, which is actually a wall type in Revit. First, I draw a wall. Then from the wall type, I select the curtain wall, and the wall easily converts into a curtain wall. I set the top constraint to L2, which means the wall starts from L1 and goes up to just below the L2 floor slab. I can then copy the same curtain wall and use it on the next level for the upper floor as well. At this stage, if we look closely at the reference image, we can see that the windows on the first floor, the floor above, the ground level are slightly set back. I moved these first floor windows about 2 meters apart, and then I copied the same setup for the next floor as well. To match the 3D model more accurately with the reference image, I create a camera view that is perfectly perpendicular to the facade. This way, I can see the elevation from the exact same angle and fine-tune the facade accordingly. Now let's move on to creating the facade wall on the top floor. It doesn't really matter where we use facade design. Up to this point, we build the base of the facade, and now we can start working on the main and defining element first. Right now, I'm going to create the wall for the top floor. I'm moving this facade wall slightly inward because that's how it appears in our reference image, and I think this is the best stage to do it. At this point, it's become clear that the top floor slab also needs to pull it inward so it sits behind the wall. So we need to edit the floor and move the slab 1 meter inwards all the way to the inner edge of the wall. We just create it. To make this more accurate, I could use a pick line, but instead I'm moving this line 20 centimeters inward, matching the wall thickness. In the next step, I need to offset the wall from the side. In the next step, I need to offset the walls from the side. From the right side, I offset 20 centimeters from the facade. The wall width is 5.30 meters, so I can draw P9 using the PL command, then offsets it by 5.30 meters. Based on the reference image, we can now estimate the height of this wall and the side walls which look to be around 2.10 meters. Now we want to create an empty section within this wall using the measurement from our reference image. We draw and dimension each line in AutoCAD based on this image. The middle section is 2 meters and the side selection is 1 meters, which means we need to offset 1 meters from the right before creating the opening. To do this, I double click on the wall to enter edit mode. From the right line, I offset copy by 1 meters, and then another offset of 2 meters from the middle selection. For the horizontal line, I use the line under the slab as a reference. Delete unnecessary line and apply flat. This creates a U-shaped valve. Now we need to create the roof parapet, and for this we use a wall. Instead of assigning a level as the top constraint, we set a fixed height of 1.10 meters. Then we switch to our camera view. Now we can move on the facade form and surface design. For shaping the facade scheme, we can go to the Architectural tab, choose a component and the model in place. Using tools like Extrude and the other available options, we can create different facade elements and surface. The first thing we need to do is go to the set working plan and define where the base of our extrude is going to be. In this step, we want to create the sheet elements that's wrapped around this opening. So we set the work plan on this wall. Then, use an extrude and the edge of this geometry as a reference, we draw the metal sheet. After picking this line, we give the sheet a thickness using offset. Connect all the line with the fillet and then confirm the sketch. Finally, from the extrusion setting, we define the depth of the elements. Since the extrusion starts from the surface and we want it to start from behind the wall, we need to move the extrusion start inward by the wall thickness. This way, the extrusion starts from the back of the wall. The wall thickness here is 20 centimeters. The next step is modeling the flower box. We set the work plan on the balcony floors, then go to Components and use Extrude, again to draw the flower box baseline. Here, I'm working with two parameters to match the flower box exactly to the reference image. The first one is extrusion start, which controls the distance between the flower box and the balcony floors. The second parameter is extrusion, which defines the height of the flower box itself. By adjusting these two values together, I find the tone the model until it's closely matched the proportion and position shown in the image. In the next step, we need to adjust the second floor wall, and our 3D model is currently fully glazed. But in the reference image, half of is a solid wall and the other half is glass or curtain wall. We take the measurements directly from the reference image and apply them to the model. Based on the image, we need to add a 3 meters solid wall starting from the right side and then the windows beginning after that. For the next step, we move on to modeling the floor box on the same floor. We take the dimension from the reference image and this time we check the distance. From the left side of the balcony, reach approximately 2.5 meters. I select some new components, then choose the floor of this level and set the work plan on it. I pick the starting edge of the balcony and offset it by 2.5 meters. After that, I draw the ring line for the floor box, confirm the sketch, and set its height and extrusion. Finally, I adjust the extrusion start to control the distance from the floor. In the next step, we model the handrails and flashing using new components and extrusion. Since there's no specific or advancing training point in this part, we move it through it a bit faster and jump into the more exciting stage next. In this step, instead of using extrude, we use the bevel tools to model the balcony edge profile. First, we need to define the bevel path. We can either draw the path or pitch it directly. And then refine it using fillets or trim if needed. Once the path is final, we confirm it. In the next step, we create a profile section for the bevels. If you look at the reference image, the profile has a U-shaped form. We create a profile section for the bevel. From the profile, edit profile, we draw the section directly on this path. You can draw any profile section you want, and that profile will follow the defined pattern. You can even add as much detail is needed to the section. However, in this case, we are keeping it simple and matching the U-shaped profile shown in the reference image. After drawing the profile, we confirm it, and with the final confirmation of the bevel, the geometry is created. At this point, it looks like the main elements of the projects are already in a place, and the model is very close to the reference image. We can now move on to adding more details. We probably speed up the video while adding the remaining details, because there are nothing new to explain and we are using the same technique we already learned. This helps us to get to the more important and interesting parts faster. Of course, if anything important come up, I explain it along the way. To import an architecture project or facade design from Revit into D5 Render, proper material assignment in Revit is required. D5 does not read the object by their geometry. It only reads the material. This means elements with the same material will be selected together, and different material can be controlled separately in D5. Revit materials do not need to be realistic or final. They mainly work as a label to define how elements are separate during rendering. If materials are not assigned correctly in Revit, controlling and adjusting them later in D5 become difficult. But for this, all we need to do is understand how many materials we need in the materials panel. We duplicate a basic material, give it a new name, and assign a color to it. For example, I will name this material D5 underline white, and then apply it to all the parts that are supposed to the white material. To assign the material to this part, which is component, I just select it, then it's the properties panel under the material setting. I assign the material we just created to. To see the material, you just need to change the viewport setting to shade it. You don't really need to add a texture to this Revit material. Using simple color is enough to visually to easily see the difference between them. If have a wall, we can assign a different material to different parts of it. Using the paint tools, once paint is active, we just select the material we want and click on the surface where we want to apply it. It's that simple. We can assign the material to the entire project using the same methods. And don't worry if something isn't perfect. Once we are in a D5, we can adjust everything later and see the change of this light. After giving material to our model, we can connect Revit to D5. So we can send our model directly to D5 for rendering. The great thing is that any change we make it in Revit will update live in D5. To do this, we need to install the Revit and D5 connection plugin. Go to www.d5render.com, open the workflow section, choose a Revit, download and install the plugin, and select your Revit version. After installation, a new section called D5 Render will appear in Revit. Click on the D5 Render tab in Revit and press Start D5. This will open D5 and your project will appear live in D5. Important: D5 must be installed on your Windows. In the previous step, we assumed D5 is installed and we only installed the sync plugin to connect the Revit and D5. After clicking Start, choose a new project to open a new project in D5. You will see your Revit project's importance exactly. Now, you can add a material, design the environment, adjust lighting, and render in the D5. I turn off the terrain because it's the surface that D5 created, and I don't need it. In the sense list, I create a new sense and click on the camera to set my view, like the reference image. Make sure to turn on fly at the top so you can move easily in the project without any problem. I want to move back a bit so I can get my desired angle by adjusting the camera setting. By changing the focal length, I can reach the view I want and get a professional looking shot of the building. I'm testing 40mm lens and I think it looks very similar to the angle of the original photo. Now, it's time to start applying materials to the project. D5 already has a complete material library, and we are going to use that in the asset section. Under material, we can search for any type of material and access all its different variations. For example, now we want to use the concrete for the white part of the project. All we need to do is select the material we want and then click on the area. You'll see that all the parts in Revit that had that material get assigned automatically. So now you can better understand how to apply material on your project in Revit. For the next material, we want a nice black one. This material library is really complete, so I recommend taking some time to explore it. Check out all the material and their variation, and for your next project, you will have a clear idea of which material to use for each part. Now, there's a part of the project we hadn't planned it for, so we need to go back to Revit and make some change. But it's actually really cool because we can do it live in Revit and see its updates in D5 at the same time. For example, at the entrance, parts of our walls is black and parts is wood. We just go in Revit, create a groove in the wall, change the material for that part, click sync model in a D5 render. The change appears instantly and we can continue working easily. The material quality in a viewport may look a bit low, but that's okay. Lighting hasn't been done, and the final render setting will give us excellent quality. Let's move on to assigning the rest of the materials. We definitely needs to adjust the UV of our material on the model. When we pick a material, we can access its setting right in the viewport. I usually use three main settings. First, stretch, which lets us scale the texture on the X and Y axis to fit the model. Second, offset, which lets you move the texture around on the surface. And third one, rotate, which lets us rotate the texture on the model. Right now, we need to rotate the material. Let's continue like this and start applying and adjusting material on this project. For the next step, we need to create the environment, including all 3D model, like tree, plants, cars, and anything else in D5. We use a D5 assets again under the model section. This part is kind of like a game. You can find anything in the library. Just grab it and drag it into the sets. You need to adjust its size using a scale parameter. I will try to arrange all the models to match the reference photo, but you can also do it however you like. Now we need to set up the lighting for the scenes. In the environment, we can adjust the direction of the sunlight. I can set the sun to any time of day, even night, depending on what kind of look we need. In the cloud setting, we can control how cloudy the sky is or even turn the clouds on or off. We can also adjust the exposure in the camera setting. The global is just to bring it to a normal balanced level. After that, I tweak the sign direction again to make it closer to the lighting in our reference image. I try to find a tone everything because I want to render the sense and move on the final step. Finally, we reached the most exciting part of the project, the rendering stage. I open the render setting, and the first thing I do is define the image aspect ratio and render quality. Here, I choose a 1:1 ratio and set the quality to 4K. If you're planning to use a D5 AI, making sure the image quality is set to 4K, not lower and not higher. The aspect ratio doesn't really matter for AI, but the quality 4K is very important. Another useful option is that I can adjust the FOV speciality for this render without changing my camera setting. I can also control the focal lenses separately. This is allowed me to create a tele or wide angle render directly from here. I can also set the image dimension to any size I want by adjusting the render width and height. You can enable any channel you need, and it will be rendered together with main image. Just keep it in mind that each additional channel increases the render time. However, if you plan to use the D5 AI, the AI channel must be enabled. So, to use the D5 AI, there are two things you must do. First, make sure your image is rendering in 4K, and second, ensure that the AI channel is turned on. Now I just need to hit the render button and wait for the render to finish. Now I just need to hit the render button and set the save as, and wait for the render to finish. A few important tips. First, make sure your graphic drivers is up to date. This can really help performance. Second, make sure you log it in with your email so you can access D5 features like assets and AI. When the render is finished, a window will be open where you can go to your render folder and see the main render aligned with any channel you create. As you can see, the render isn't bad, but what we really want is higher quality render. You could spend more time in the design to get a higher quality output. But in this tutorial, I want to introduce you to the AI image in the D5. To use this feature, just click on an AI post-processing and enter the AI word in the list that appears. Select the render you want and then go to the AI style transfer section. Here we have two main sections, stylized and realistic. In the stylized section, we have a fun, creative style like a colored pencil, pastel, and a sketch or model-like look. You can try them out. They are really cool, and you can transform your render into any of these styles. The next section is realistic, which includes several styles that make your render look more realistic. This includes different seasons like summer, autumn, and even winter, which adds snow to the sets. For example, here I'm testing the spring style. You can see how realistic the image looks now. You can easily download the image in a high quality. In the next step, there is another option here, the last one. Call it Style Transform from Reference. This feature lets you use the lighting, shadow, and colors from the reference image and apply them to your render. It only transfers the render style, color, and lighting, and it does not change your design at all. Here, we are using the same Pinterest reference image with stars with. You can see how close the lighting, materials, and shadow are the reference image, even better than the original photo. In the next step, I'm going to apply unrealistic style to the same render so you can see and compare the results.